Hi, I'm Yunsung Lee, a machine learning engineer at Written Technologies. I'd like to present our research, multi-architecture, multi-expert diffusion models. This research will be presented at AAAI 2024. The moral of the famous idiom, there ain't no such thing as a free lunch, seems to hold true for diffusion models as well. When making a diffusion model cost efficient, we usually have a performance trade-off. Previous studies of efficient diffusion models have been unable to get away with this. But with MIME, you can have a free lunch. MIME makes diffusion models 3.3 times faster, but the performance is even better. Here's our journey to get there. If you think about it by default, diffusion models suffer from a variety of different denoising tasks. In close proximity to noise, diffusion models fill in the low-frequency components first. As denoising progresses, diffusion models fill in the high-frequency details. The same conclusion can be reached by looking at the Fourier spectrum of the inputs used to train the diffusion model. This seems self-explanatory, as we are essentially performing a denoising process that is the inverse of the diffusion process. The following shows that this problem is indeed prominent in current diffusion models. Here is a visualization of related log amplitudes of Fourier transform feature map obtained from the pre-trained large LDM. You can see that the diffusion model is more sensitive to lower frequency when dealing with large time steps, which means near noisy inputs. You can see that this trend is consistent across all layers. Again, diffusion models need to learn a variety of denoising tasks at once. This may have been a difficult task for a single model to learn. Maybe that's why we have to make the denoising model size of diffusion models so large. So, let's learn from our daily lessons. The collaboration of many people produces better results than one giant. It can be more efficient to have multiple denoiser models than just giant one. It's an interesting idea as it is, but we go one step further. Rather than a one-size-fits-all collaboration, a collaboration that combines the strengths of variety people's synergy will be more effective. That's why we propose multi-architecture, multi-expert diffusion models. Expert models from different architectures will be active in the time step interval where they can best fulfill their jobs. To accomplish this, two questions come to mind. So, how do we bring together a diverse group of people? Well, all their different strengths is effective. Since the advent of vision transformer, self-attention and convolutional properties have been analyzed extensively. One of the conclusions is convolution favors high frequencies and self-attention favors low frequencies. Now, we can establish the design principles of MIME. We'll use different architectures using self-attention where we are dealing more with lower frequencies and convolution where we are dealing more with high frequencies. Now, how do we control the ratio between convolution and self-attention? We leverage the I-formal block. This allows us to manipulate the ratio between convolution and self-attention. We propose a new denoiser unit called IUnit. This is our overall quantitative result. You can see that we have achieved the free lunch I mentioned earlier, the construction of a more efficient diffusion model that performs well. Next, You can see the qualitative results. You can find more results and detailed explanations in our paper. Thanks for listening.